Okay, so I'm trying to create a project, and this is the sprinkler that the boys made in science class, that when it's just tubes. These are just actually plastic straws, and when you spin it, it's gonna throw water. Isn't that cool?
Oh.
It creates an eddy that pushes the water up, and it flies out these ends.
Cool.
Isn't it? It's pretty cool. So then I thought it would be fun to wire up the Arduino board with a temperature sensor, so that when the temperature gets above a certain temperature, then this motor kicks on and it spins it. So I got to figure out a way to either use this as my prototype or build a sturdier one, and a way to connect the motor. I haven't decided if I want to connect the motor on the bottom and have it underneath and have some type of gaskets, have some system where I drill through it and have the motor spin it from underneath, or some kind of bracket and the motor spin it from above. I haven't really figured that out yet. You're thinking.
And what we're trying to do is spin this triangle, which has straws that will siphon the water out of the dish.
Mm-hmm. Yes.
Am I comprehending it?
Yep, that's the goal. Because, like, if you did like a life-size version, like, okay, like that's a person, and this is like a water fountain, and then it's on a sensor, then when it gets too hot, it kicks in and it sprays water and cools you off. You're my black hat. You bring me back to reality. Like, what in the world? Okay, so that's my goal. So here's what I wired, okay? Are you familiar with an Arduino board?
No.
Okay. So what this is, I'll put the water away from the electronics. So you're familiar with circuitry, and you're familiar with, you know, loops and all that. So underneath here, all of these rows are connected. So everything on this row is connected to each other. So it's like a plug and play. Okay. You don't have to solder the wires in. So, but this row is separate from this row. Mm-hmm. And this row is separate from these rows. And then this is all one length for the negative and positives. Does that make sense?
Is one row negative and one row positive?
It's whatever you want it to be. It's whatever you connect it to be. So right now, this is labeled negative, so I always use that as negative. I always connect it to the negatives.
Good morning.
Hi. And then over here is like a microprocessor, like a miniature computer. Mm-hmm. And on my computer or any kind of device, you can write the code to give it directions. So what I did is I wrote code for this processor to say, I want you to read this temperature. There's a little temperature sensor, and you get to set the value. I set the value at 56 degrees Fahrenheit. When it gets above 56 degrees Fahrenheit, it goes to the input. So there's the input, the white wire is the input.
Okay.
Okay, so then it talks to here and it says, okay, finish the rest of the directions. So then I typed in the directions that once it gets above 56 degrees, then I want you to turn this LED light on, and I want you to turn the motor on. So this group of stuff is for the LED. All of this group of wiring is for the temperature sensor. And then this is all the motor. The motor has to have a diode. This is the first time I've ever messed with a diode. That's the resistor, and that's a transistor. And I don't completely understand the diodes and transistors.
Diodes only allow electricity to flow in one direction.
Okay, that makes sense. Because it said that...
Positive and negative.
Okay. It's got a black line. Do you know what that means as far as the direction?
Yeah, on one side positive and the other side negative.
Right. Do you know which is which?
Not without them being marked.
Okay. I don't either. I have to look into that. Okay. Yeah, the book said that electricity is like water and that it will follow the path of least resistance.
That's correct.
And so you have to have that diode in place because the motor draws so much current that it'll go somewhere else. And that sometimes when the motor turns off, you'll get a surge and it'll backflow and it can burn stuff up. A spike. Okay, spike. Okay. Now,
Yeah.
normally,
It's like the electricity is going along, driving along real good, and then you stop it, it kind of backs up and and runs up
oh, I see. Okay.
so that energy,
Has to go somewhere.
yeah, it's going along and then it's got to go somewhere. Oops.
And you don't want it to go back into the board and burn up your circuits.
Well, you'd be real unhappy, yes.
Right. That's like hooking up a car battery the wrong way. Not a good
Oops.
not a good idea. Yeah, well, oops, and a lot of money to fix that. So I thought I burnt this up last night because I got the motor to run and then it stopped and then the computer program kept getting errors and I'm like, oh no, we burnt it up. But it's working again today. So
This thing hooks into a laptop.
it hooks into this port right here. It has a cable that then has a USB slot. They'll hook into whatever has a USB. So what I did is I already downloaded, well, I guess uploaded. I already uploaded the program into this system. So I can unhook it from the computer. Now I need a power source. If it's hooked up to the computer is also the power source.
It's got a battery in it.
So this came with the kit as an alternate battery source. So we're not chained to the computer now to see if it works. We can't play with the code and change the code without hooking it up again. But so here we go.
You have to hook it back up to the computer.
If you want to change the directions. Right now the directions are already been written.
Programmed.
It's been programmed. The board's been programmed. If you want to reprogram it, then you got to hook it up. Does that make sense?
Yeah, I knew about programmed and pre-programmed. I'll think of the name of those in a minute. Yeah, you could get them either way. You could get them already programmed, or you could get what they call programmable ones that had a minimum amount of programming, but then you could add whatever you wanted so it would do what you want.
Right. Are you okay if I film like your face? Is that okay if I film your face while you talk?
Sure.
Okay. All right. So are you talking
But
about...
ugly and all.
Oh, whatever. Not at all. So what are you talking about, like when you were doing AC work?
Yes.
Okay.
What do you mean, AC work? I don't understand.
You're talking about you could buy programmable and not programmable. In what application?
Oh, you would use it for the quote-unquote brains for your air conditioner
Okay.
or your furnace.
Uh-huh.
It has to decide, okay, well now I've got a signal. I need to turn on the heat. What do I need to do that? Well, it decides, oh, I need to light a pilot light. And then we need to let some gas, natural gas, come in there on top of that pilot light to light. Once we get a good flame going, we need to have some way to verify we have a flame. So we have to have a infrared eye that says, well, hello, we got a flame. We got gas, we got power, we got a flame. We have, Houston, we have liftoff. So, all right, now we've got the fire going in the firebox. And that's just a name for the box, for lack of a better, that holds all the heat in and heat's on the inside from the natural gas,
Right.
and on the outside it's a hollow box. The outside air goes around the outside,
Okay.
and you heat up that air, and you have a fan pushing that air across the outside of your heat exchanger. And that's what it does. It exchanges heat from the inside to the outside. And the outside is your house. It's outside the firebox.
So it's kind of just a more elaborate system of what I have. You have sensors that if this sensor gives the right input, then this will happen.
Most of the sensors are for safety precautions. Okay, your brain says, all right, I've turned on the switch and I've turned on the gas. What if it didn't ignite and just had natural gas blasting into the firebox?
Oh, that would be bad.
That's why you have sensors to check to make sure that, yes, in fact, Virginia, we do have a fire. So these are safety devices to make sure that everything's going as planned.
Okay.
And absolutely essential.
Right.
And these safety devices go back to the early days of forced air furnaces.
Yeah.
Because if you had something go wrong, if you had an idiot put the wrong spring inside of a gas valve and it's stuck open, that would be me.
Oh, you've done that?
Yes. I was being a wise ass. Had a bad gas valve. And I thought, well, I just changed it. The spring broke inside the gas valve. I took it all apart and, oh, I see what it is. I'll fix that. I got a ballpoint spring here. Doesn't work.
Not a good replacement.
No, it does not work.
Okay.
Almost burned a house down.
Oh.
Yes, being a wise ass.
Oh.
Cheapskate.
Oh dear.
Yeah. Because the electricity went off, but the valve didn't close because the spring was not correct.
Oh, it wasn't strong enough.
You know, wasn't whatever it was.
Yeah.
And the valve stuck open and kept on feeding gas in there. And fortunately, now in those days you didn't have you just had a pilot light. So it kept the gas burning because the electricity was off, but the gas was still going through the valve, and it was staying hot.
Yeah.
Almost all of the devices, control devices, are run by electricity. Usually 24 volts, 28 volts AC. You take house current 120 and you step it down to 28 volts.
Okay.
And that's the normal voltage, control voltage of your furnace. Doesn't have to be, it just happens to work out that way.
Right.
And
So you learned.
so I learned to not be a smart aleck and try and cut corners. I was not nearly as smart as I thought I was. And,
Well, hopefully this isn't as essential to get right. Okay, so I took the power leads off. So let's see, this one is the 5 volt. So I'm going to try the 5 volt over here, which is the motor. And this is 3.3 volt. So I'm going to do this over here. And then the sensor has to get above 56 degrees. So I kind of make some friction on my fingers. And then I hold the sensor. The LED should light up when it gets... Okay, earlier it was not working. Earlier I could get the LED to light up, but the motor wouldn't turn on.
Did the motor turn on?
It is now. And then when it cools off,
It'll shut off.
It'll shut off.
Fine. That's fine.
well, it wasn't working earlier, and I was going to ask you why it wasn't working earlier. And now it's like, you know, you take the car to the mechanic and now it won't act up.
Uh-huh.
I don't know if it's because now I have it hooked up to the 9-volt and it has more power. I don't know.
What did you have it hooked up to before?
The computer, the USB port on the computer. Now I'm going to do 3.3 there. I switched the power sources. No, it doesn't matter. We'll see if it turns off after it cools off. I thought that because I had jumped over here, that I wouldn't have to have ground and power on both sides. But apparently something's wrong in my circuitry. So like this is like obsolete. This actually doesn't do anything. I had to actually do a separate ground and a separate power on both sides of the breadboard. Just jumping the power over wasn't enough.
Mm-hmm.
I don't know why.
Should have been.
Should have been, but maybe it's because of the direction that I'm sending things, and it's being used up somewhere else and it doesn't have enough to come over. I don't know.
Well, wait a minute, this is DC current.
This is a DC motor.
Yeah.
Yeah. So is the whole system DC current?
Yeah, because you're working off a battery. There's no way it's going to be anything but.
So that's DC. Batteries are DC.
Yes.
That's why in a car, when you have those plug-ins, you have to have an adapter if you want to plug in a regular type plug. Like if I wanted to plug in a TV, just a regular TV in a car, you can't do the cigarette lighter because the car's direct current.
Correct.
And the TV's alternating current.
That is correct.
Okay. So I'm just going to play around. Well, it's working now, so I don't know what I was doing wrong earlier. See, I thought that by jumping it over, I wouldn't have to have...
Oh. Oh, no, you've got to have power cables right to you, whatever you're operating, your motor in this case.
So just having the power to this side and then jumping it over to this side isn't enough?
You have too much...
Too much going on?
Yeah. Droppage. You have too much resistance.
Too much resistance. The power wants to go somewhere else.
The power will. I'll say the words in a minute.
Mm-hmm. Yeah, it's just not happy. It has to have its own. Each side has to have its own power and its own ground.
That's right.
See? Boom. There it goes. I have to tell you, I have been struggling with this circuit for a week and a half. Well, almost, yeah, a week and a half. All last week, I couldn't get the sensor to communicate correctly. I couldn't write the code right and get the circuit right for both of them to work. Same thing with the motor. The diagram and the code in the book doesn't seem to work well for the motor. So then I went online and I found a different way to wire it and a different code. I mean, I was resorting to...
You got the wiring diagram?
I do. I'll show it to you here in just a second. I had to finally, because I tried to combine everything all at once. I thought I was going to be smart. I don't know where I got that from.
I have no idea.
Oh no, right? I thought I was going to be a smart aleck. And I thought I was going to do all of it all at once. I would have the sensor and the motor and they would just all be happy and just magically happen. And it didn't. So then this week I deconstructed it. I went back to making the LED light turn on. Okay, I remember how to do that. Kind of build my confidence back up and remind myself. Then I got the sensor to work. Then I got the sensor to turn the LED light on at a certain temperature. I'm like, all right, we are making progress.
All right.
I was getting pretty happy. Then I independently figured out the motor problem and got the motor to run. I don't know what I was doing wrong last night. I thought I burnt it up because I was getting error messages. Because I tried flipping the diode. Because the picture in the book, another peer said the picture in the book has the diode on backwards. So when it didn't work, I switched the diode, and I thought maybe I burnt it up.
Because it could have, but you didn't have enough current to do that.
Well, it turned on, and the way the code was written when I was doing just the motor was I wrote the code for